Welcome. In this set of tutorials, we're going to be learning all about so-called vectors. Vectors play a key role in physics, and we're going to learn what they are, how they arise, why they're useful, the various fun and games we can have with vectors, how we can analyze problems with vectors, and so forth. In physics, you're going to encounter many different physical quantities. Things like forces, electric fields, magnetic fields, mass, electrical charge, and so forth. And broadly speaking, we can classify these different physical quantities into two categories, scalars and vectors. And let me explain the difference between the two. Let's start with scalars. Some physical quantities in nature can be described as ordinary numbers. For example, mass. If I say, what's the mass of this elephant, you'll give me a number. You'll say, perhaps it's 4,500 kilograms. If I say, what's the length of this pencil, you'll respond with a number, maybe 10 centimeters. If I say, what's the temperature of the room, you might say 20 degrees Celsius. If I say, what's the electrical charge inside this nucleus, you might respond, it's 2.24 times 10 to the negative 18th coulombs. If I say, what's the energy contained inside this battery, you might respond, 60,000 joules of energy. The point is, your responses were in the form of a number. You told me the size of something. And we call physical quantities, like mass and length and so on, that are described by just an ordinary number, we call those things scalars. However, certain quantities in nature have both a size and a direction, and we call these things vectors. Some examples of vectors are forces. For instance, if I push on you, it's not good enough for me to just say how hard I pushed on you, but I have to say the direction that I push you in order to fully specify the force. Likewise, imagine you see a particle and it's moving through space, and I say describe its velocity. It's not sufficient to just tell me how fast it's going. You also have to tell me the direction that it's moving. So force and velocity are two examples of vectors, quantities that have both a size as well as a direction. Other examples of vectors that you'll learn about in your physics course include momentum, magnetic fields, electric fields, and so on. So what we're going to do in this set of tutorials is see, what are these vectors? How do they arise? What are the things that we can do with these vectors? How do they behave? So the first thing to know is that vectors are extremely easy to represent because we can just use an arrow to represent them. Let me give you an example. Suppose I push on you with a force, and the strength of the force is 6 newtons. A newton is a unit of force. And I can draw this arrow here to represent the direction of the push that I'm giving you. So this red arrow here represents a 6 Newton force push in this direction. I might want to give this force vector a name. I might call it F. And to remind myself that this isn't just an ordinary number, but it has a direction, I put the little arrow sign above the F. That indicates that this force is a vector. And if I wanted to note the size or the magnitude of the force vector, I put absolute value signs around the vector, and in this case, the size of this force vector is 6 newtons. Let me give you another example. I want you to imagine a particle that you're watching, and you see that it's traveling to the right at 11 meters per second. So you can represent this motion by using a velocity vector. So here I've drawn the vector showing you the direction that the particle's moving, and I've labeled above the vector its size or magnitude, how fast it's moving. In this case, 11 meters a second. I might want to give this velocity vector a name. I might call it v for velocity. And I, again, note that there's an arrow above it. That reminds me that this velocity is a vector. It's not just a number, but it has a direction as well. The magnitude or the size of this velocity vector in this example is 11 meters per second. Let me give you another example of a vector. This time it's something called the displacement vector. I want you to imagine that you're looking at a ball, and the ball starts out on the ground and then it rises 5 meters in the air. So it changed its position. It went upwards a total distance of 5 meters. So we call this thing a displacement vector. It tells you the change in the position of the object. And we might want to give this displacement vector a name. In this case, I'm calling it d. Again, note the arrow above it to indicate that this is a vector. It has both a size and a direction. The magnitude of this displacement vector is 5 meters. More generally, when you have a vector, we can represent a general vector A in terms of its size or magnitude. We denote it with the absolute value signs like I indicated before, here, here, and here. Or sometimes people will just draw the vector A, but they don't actually put the arrow above it, and that indicates that you're just talking about the size of the vector A. So here's a vector A, and this is the magnitude of the vector. By the way, when you draw a vector and you put the magnitude above it, the magnitude of a vector is always a positive number. So you're not going to see a vector with a negative magnitude. Lastly, I just want to define something called a unit vector. Sometimes the length or the magnitude of a vector will be 1. So for example, suppose I had a vector A whose magnitude was 1. Then I'm going to call that a unit vector. And to denote that vector, rather than putting a little arrow above it, I instead put this little caret above it, sometimes called the hat. And so a hat here represents a unit vector. The hat tells me that it's a vector whose magnitude is 1. The reason why I mention it, it's not like these unit vectors are the most important thing in the world, but they do turn out to be useful. And let me give you kind of a preview of how they're going to be useful. When you're analyzing different physical situations, you're often going to draw a coordinate system. So for example, here's a three-dimensional coordinate system, x, y, and z. So in this case, the x-axis is pointing to the right, the y-axis is pointing upwards, and the z-axis is coming out of the page. So I can define these so-called unit directional vectors. I'll denote them x hat, y hat, and z hat. X hat is a unit vector of length 1 that points along the x-axis. Y hat is a unit vector that points in the y direction. And z hat is a unit vector that points in the z direction. As I said, these things will be useful. These unit vectors will be useful a little bit later on, particularly when we start talking about breaking vectors into their components in a later tutorial. You'll see why these arise.